So over here we can get this one. Bromide ion act as a nucleophilic reagent to attack on carbon of protonated ether. So during this process, 1 mole bromoethane, that is the ethyl bromide, and 1 mole of ethanol are formed. That is CH2, CH3 with O, and then CH2, CH3 with hydroxide and Br. So see the protonator over here, the bond will go over here, and this electron will go over here. So what it forms? It forms CH3CH2Br. So that's over here CH3CH2Br, and what is remaining? CH2CH2OH. It is somewhat like this. See here, take a bond like this. So this bromine is attached over here, that is CH3CH2Br, and we form CH3CH2OH over here. That is a bromo, ethane, and ethanol. Okay. Ethanol is converted to protonated ethanol by accepting proton from the hydrogen bromide. That is CH3CH2OH. It reacts to the hydrogen bromide fast. It gives CH3CH2 and OH, and H is added over here. So it's a protonated ethanol plus bromine is removed. So the hydrogen replaced over here and bromine is removed over here. So in this form, the ethanol is converted to protonated ethanol by accepting the proton from the hydrogen bromide. The step 4 is what? Bromide ion act as a nucleophilic reagent to attack on the carbon of protonated ethanol. During this step, bromoethane and water are formed. So that is CH3CH2OH with the hydrogen added over here plus bromine. With a slow reaction, what it forms, see here, the bromine will attach over here and water is replaced, water is removed. So it forms a bromoethane. So slowly it forms CH3CH2 with bromine with the 6 electrons over here. Yes. Now the next one is an electrophilic substitution reaction occurring in an aromatic ring. So for that, the first thing is what? Nitration process. So in this, the OR group of alkoxyarene compound being orthopara directing their electrophilic substitution reaction give mixture of orthopara products. These reactions will be understood by the following examples of anisole. Nitration, the nitration reaction of anisole with a mixture of a concentrated nitric acid and a concentrated sulfuric acid gives a mixture of a 1-methoxy-2-nitrobenzene, that is ortho-nitroanisole, and 1-methoxy-4-nitrobenzene, that is a para-nitroanisole. So anisole means, you know, that is benzene being with OCH3. On the nitration process, we are getting the ortho and the para position, that is ortho-nitroanisole and para-nitroanisole, or we can say 1-methoxy-2-nitrobenzene or 1-methoxy-4-nitrobenzene. And the anisole, the bromination, same process, ortho-bromoanisole or para-bromoanisole, or 1-bromo-2-methoxy-benzene or 1-bromo-4-methoxy-benzene. Okay. Here in this, what is the difference? One is in the position of the methoxy and 2-nitro is there. Here you are having a 1-bromine, first bromine and then 2-methoxy. What it shows, that is bromine is more reactive than the methoxy. And here methoxy is more reactive than the nitrobenzene. So that is somewhat shows the numbering difference. Now the next one is what? Phytochrome alkylation process. The Phytochrome alkylation was reaction of anisole with a chloromethane that in presence of anhydrous aluminum chloride, that is AlCl3, which gives 1-methoxy-2-methyl-benzene or orthomethoxytoluene and 1-methoxy-4-methyl-benzene, that is a para-methoxytoluene. So anisole in the presence of CH3Cl and AlCl3. And what happens over here? CH3 is attached over here in the ortho position and the para position. So it forms 1-methoxy-2-methyl-benzene. And over here, 1-methoxy-4-methyl-benzene. As you know that methoxy is more reactive than the methyl group. Now, the next one is what? Some organic conversion over here, which is very, very important. This is very, very important. So here there is a conversion of 1-methoxy-2-nitrobenzene and 1-methoxy-4-nitrobenzene from sodium phenoxide. So from sodium phenoxide, we have to understand if from sodium phenoxide means benzene ring with ONA, that is sodium phenoxide. What we will do to get methoxy-nitrobenzene? So for that methoxy-nitrobenzene, we need to add what? Methoxy, like OCSA anisole. So CH3I is required. So NaI. Okay. In the first equation we have shown. So from the sodium phenoxide, in the presence of CH3I, we get anisole. Now with the anisole, methoxy content form, only the nitro form 2 and the nitro 4. That is also in the para position we have to find. So nitration in presence of HNO3 and the sulfuric acid, we are getting orthonitro-anisole and para-nitro-anisole, or we can say 1-methoxy-2-nitrobenzene or 1-methoxy-4-nitrobenzene. Okay. Now the second conversion is what? Ethanol from acetic acid. So think acetic acid is CH3COH. Ethanol is aldehyde. How you will get? Obviously, it's the oxidation process LiLH4 from the oxidation acetic acid to ethanol, alcohol, and from pyridinium chlorochromate PCC CH2Cl, we forms what? The water is removed over here and oxidation is processed over here. So it forms CH3CHO. Okay. So this is ethanol, or we can say aldehyde. Now bromoethane from ethanol means what? CH3CH2OH. So from this we are getting one bromoethane. How we will get in the presence of H2SO4? That is, first we have to take ethoxyethane, that is C2H5OH, O C2H5O, and then C2H5 ethoxyethane. With the bromination, we get bromoethane plus water is removed. Next formation is what? Propane 2-ol from ethanol. Ethanol is the aldehyde, CH3CHO plus from that uric propanol, alcohol. So methyl magnesium bromide, that is Grignard reagent, CH3 and GBr gives CH3C, CH3 over here, and then OMGBr will be over here, right? See, O is attached with the MGBr, one is CH3 attached over here, right? So we'll get this one as a intermediate. So from the hydrolysis, we are getting it CH3CH, CH3. Actually, this will become only hydrogen, but it is incorrect. So now it is CH3CH. This CH3 and O or MgOH Br is replaced, and that is replaced by the hydrogen. So it's a propane 2-ol. So see here OMGBr, right? This CH3 is attached over here, and this hydrogen is will be same only. Okay, so understood the correction part. Now the next one is a nitrobenzene from phenol. So that is quite easy. From phenol, there is zinc powder, then an O removed. So benzene is formed. So from the benzene nitration in the presence of HNO3 and the sulfuric acid H2SO4, they are getting nitrobenzene. Okay. Hope you understood the topic very well. This is the completion of the chapter. Kindly do the practice of the conversion of the equation. Okay. Thank you. Hope you understood the topic very well. Bye. Have a nice day.